Hello everybody, welcome to Alexa's LeetCode. The contest is about to start. No, we do not provide the solution until the contest finishes. So hang on to your hats, try them yourself first. I think that's the best way to learn. Try the questions out yourself, and once the contest ends, we'll be going on over the answers. Alright, good luck everybody, see you in about 1.5 hours. If you have questions, feel free to ask in the chat. I'll try to answer them as much as possible. All right. Welcome to the chat. If you just join us, remember you can still do the. Oh shit! Sorry about echo there. Welcome to chat. Remember you can still join the contest. You're not in time. We just started 3 minutes ago. If I can't give you, I don't share answers during the contest. It's not allowed. But if you have questions, I'll give you small hints in the chat. So type in the chat, and let's talk. Hey Rohan, how's it going? Welcome to the chat. If you just joined the chat, welcome, welcome. Remember, we don't provide answers. Well, I don't provide answers. During the contest itself, it's not actually allowed by LeetCode, and it's also not a good way to learn. So feel free to work on the contest yourself. We'll be discussing answers at the end. If you have questions, I do provide, I do answer your questions. So feel free to type them out in the chat. I will try to get to you. Question 2 is kind of confusing for me. It is hard to understand what they're talking about. I think I get it, but I think I know what it is asking for, but it's kind of tricky. How's everybody doing on the contest? Hope all is well. Yeah, hope all is well. Let me know if you have any questions or if something is confusing to you. I can tell you that some things are very confusing to me. But if some things are confusing to you, let me know. Ask in the chat. I might be able to help. Question 3 is interesting. Question 3 is interesting. I wonder what question 4 is. Welcome to the chat. People who just join us, welcome, welcome. As usual, I can't give you the solution during the contest, but if you have questions, feel free to ask in the chat. I'm surprised nobody asked about question 2. Question 2 is confusing. Well, to me anyway. Yeah. Okay, I see some questions. So, Rohan, which question are you talking about? I'm gonna try and help you first. How to find the max of each column in first queue? Aha! That's interesting. It depends on what language you're using, but the matrix is a 2x2 array, right? It's a nested array, so it's not 2x2, but 2-dimensional array, right? So to find, so basically, what you want to do is to go through a column. So if I say, column 5, you just do one for loop that goes through all the items in column 5. So there's the number of rows, which is n. So your for loop will be like from 0 to n minus 1, or 0 to I less than n, I plus plus. And then you say, oh, column blah, I. Does that make sense? So it's like finding, it's like regular, you're finding the maximum number in a list of numbers. But what you want to do is to go through, you want to iterate through all the column, whatever, column C or column N or whatever, whichever column you want to get. Okay. Hope that's helpful. So HB, if you're still stuck, ask more questions. I try to give like gentle clues first, so I don't give away the whole answer. So HB Pavilion. Any clues how to do a second question? Let me see. I do want to give you a clue for a second question if I can. Second question. Is it clear what the second question is asking for? Is it clear what the question is asking for? So basically you have you want to, so let's see if I can just briefly draw this. Yeah, basically what the question is asking for, I can't scroll too far down, is for you to have a pattern, right? So let's say this is 1, 2, 3, 4, 5, 6. Okay? So 1 to 2 is up, 2 to 3 also up, 3 to 4 is up, 4 to 5 is up, 5 to 6 up. So what this means is that you can think of it as 1, 1, 1, 1, 1. Okay? Right? So this is what you're doing. So in this question, what it's saying is that if it goes up, it's 1. If it's equal, it's 0. And then if it's equal, it's 0. And then if it goes down, it's minus 1. So this one up. So this 1, 1, 1, 1. So the idea here is basically you're going to look for this pattern. How many times does 1, 1 appear in this 1, 1, 1, 1, 1? It appears 1 time, 2 time, 3 time, 4 times. Does that make sense? So the first step is to calculate what is the modality of your base array. Given this 1, 2, 3, 4, 5, 6, you need to turn it to an array that goes, you turn it to an array that looks like 1, 1, 1, 1, 1 because it keeps going up. Up is 1, level is 0, and down is minus 1. So same thing for this one is 1, 4, 4, 1, 3, 5, 5, 3, right? So this is up, this is level, 4 to 4 is level, 4 to 1 is down, 1 to 3 is up, 3 to 5 is up, 5 to 5, 5 to 5 is level, 5 to 3 is down. Okay, so this is 1, 0, minus 1, 1, 1, 0, minus 1. And so what you want to find is this pattern. How many times does this 1, 0, minus 1 appear? It appears here and appears here, right? I hope that was helpful, HP Pavilion. Let me know in the chat if it's useful to you. Oh, now I have to turn off my all right. Interesting. So if people are interested, I actually skip from question 2 to question 4 because question 2 and question 4 are very similar. I'm pretty sure I can get question 4 just by modifying the answers from my question 2. I haven't got it yet, but I'm pretty sure I can get it. The only difference is that it uses an extremely large data set, so 10 to the power of 6, which means that you need to make sure it's very fast. The basic idea is exactly the same, you just need to make it super fast. Coding IT. What is the difference between number of subarrays that match 1 and 2? What do you mean by what's the difference of number? Which question are you talking about? Are you talking about question 2? Coding IT? Let me just turn off my heater first. What's the number of subarrays? Yeah. I've done. I want to do 4. Okay. What's the difference in the number of subarrays that match 1 and 2? So 2 and 4 are the same question. But 4, if you see the size of 4, is huge. So 4, the length of the array, the nums, is 10 to the power 6, which means your solution must be linear. It has to be very, very linear. Yeah. You can give it a try. I'm still working on it. Sorry, I won't be able to give you more help than that, unfortunately, because I'm still working on it myself. But I can tell you, if you put the same answer in, it will work for most cases, but you get TLE right at the end. So the really, really big test cases will cause your question 2 solution to time out. Otherwise, the 2 are exactly the same. Hi, Sunbuff. Hi, Sunbuff Jane. Welcome, welcome. Just completed my top 2 questions. Well, congratulations, Samba Jane. By the way, where am I from? I'm actually based in New York, in America. That's why my channel, my streaming times are listed in EST, which is Eastern Standard Time. Yeah, it's a nice place. It's actually winter now, which is why just now earlier in the contest, some of you hear my heater going. It's actually pretty cold here. I know many of you come from a warmer climate. Hopefully your winter is the weather is treating you nicer than it is me. You know what, guys? I take it back. I was wrong about question 4. I finished question 3, but question 4 turns out to be even harder. It should be, in theory, it's the same answer as question 2. You just have to make it faster. But the faster is not as easy as it's not as easy as I thought it would be. So Samba Jane, is GFG good or LeetCode good for placement purposes? By placement purposes, are you talking about interviews? Are you talking about like tech interviews? If you're talking about university placements, I have no idea. So tech interviews, I can tell you what happens in like big tech companies in Silicon Valley, FANG type companies. Actually, most tech companies in Silicon Valleys will require you do some kind of, like LeetCode style question. Actually, I should probably release a video that answers this question. The sort of short answer is that the medium questions are really good. The easy questions are really good. Most of the time, they will not test you on the hard questions because the hard questions is like it's trick, right? Either you know the trick or you don't know the trick. So for good companies that do good interviews, they will generally test you on something that is, especially if you're a fresh graduate. If you just graduate from university, they'll test you LeetCode, easy or LeetCode, some medium questions. So if you're really good at the easy and the medium questions, you should be good to go. Okay, because those test your foundation. For the hard questions, probably not. I don't think they're very useful. The other thing that they might test you is they might test you on like, they'll give you not like LeetCode question, but a real problem that they have. They're real code based with a bug, and they may say, "Oh, look at this program and try to debug it." So those will require you do more normal programming. So those you want to train for those, my advice is find a coding project that you like, build a web server, or whatever, or like some kind of web app, build a game, that kind of thing, and practice with that. LeetCode is not very good for those. Alright, guys, I was wrong about question 4. It's much harder than I thought it would be. I finished question 1, 2, and 3, but question 4, I'm still getting TLE. Especially for very large windows. When the window is very large, that's where the TLE comes in. Or the N is very large. Oh, very nice, Swastik. Good job. Very nice. Do you manage to finish all 4 questions? Congratulations. I hope you saw my celebratory firecrackers, I guess. All but not 3. Well, 3 is a bit annoying. 3 is a bit annoying. I will give you that. But you know what? You should be proud of yourself. So if you solve 3 within the next 22 minutes, you'll be able to complete the programming contest, which is quite a feat, actually, I have to say. Very few people actually complete the programming contest. Yep, I'm still not getting it for some reason. Involve you're getting runtime error. Is that a TLE? Is it a timeout, or is it like an actual runtime error? Convert the patterns in substrings and compare to reduce time. Maybe. I think this is language dependent. This might be language dependent. So unfortunately, I'm working in Python, which is not the fastest language. What language are you using, HP Pavilion? I think like this kind of languages, C and C++. If you use like either a bit array, it'll be quite fast. C++. I don't think converting parents into substrings will save time. If you use some kind of bit array, like if you instead of using an array of integers or array of whatever, it's just an array of bits, then it can be quite fast for C++. So because your one like is 0, 1, 0, and -1, right? So you can represent that with 2 bits. Or actually, if you just use represent them as bytes, it can be quite fast. Ah, 15 more minutes. Yeah, I'd like to see what your solution is, Swastik, later on when you once the contest is over. I'm curious how you managed to solve it. It might be a Python thing because I'm in Python and it's not. It's kind of slow, to put it mildly. I feel like I'm doing something wrong. If I can see what the timeout test case is, it'll help a lot. But too bad. Oh, you want to give me a hint? Yes, yes. Please give me a hint. Yes, please, Swastik. Mm-hmm. And then matching. Interesting. Do you do anything clever for the matching? I'm just curious. Kind of like string matching. Yeah. That's the same thing I did, but mine is slow. Why? Yeah. That's pretty much the same thing I did. KMP pattern. I don't know that one. Thanks, Samuel. I'll have to look it up. Knoof Morris pet. Yeah, interesting. I don't know this one. I guess you need to know the specific. Yeah. Hello, Aniket. How welcome. I won't be able to. Well, I guess I won't be able to finish implementing the KMP algorithm, but I am on the wiki page now. I'm gonna see if I can understand it enough to to talk about it in the answer discussion. Also, since we are almost at time, I just want to do my usual shameless plug. If you enjoy my work, if you enjoy coming to this channel and watching my stream, I will be very thankful if you throw me a like and subscribe on my channel. It helps a lot, especially for small content creators like myself. It also helps you be notified when I have a new video. I intend to have one video actually talking about the stuff that I think someone was asking before about what do you use LeetCode? Is it useful for doing interviews? What's the interview process like? I know some of you are still in university, so might be interested in that kind of topic. Longest prefix, nice. Longest prefix that is also a suffix. Interesting. Let me see. All right. All right. That's the end of the contest. So let me just change this. Okay. Not able to get third one. Summer Jane, are you? Oh, you're not working at Amazon? It's too bad. You know what? It's overrated. How old are you guys? I'm wondering. Are you guys all in university? About 1920? You've got a lot of time. You can slowly apply. Make sure you try to get internships. International internships are very much encouraged. I think you can always apply for most FANG companies would have freshman internship. So even if you're a freshman, you can apply. They tend to be easier to get if you're in the US. Oh, you're 24? My rank is very bad. Please don't look at my rank. My rank is horrible. Yeah. Also, I kind of cheated because you guys gave me the hints for KMP. You are 21? No, I'm not gonna show. It's very bad. I can tell it's very bad. And anyway, you guys gave me the hints for KMP. So even if I get my rank, it's not actually my rank. I don't deserve it. Has recession affected job hiring? Yes, that I can tell you because I'm actually I don't do anymore. I'm actually teaching at a university, so I'm a professor now. But last year I was still working as a software engineer at a FANG company in Silicon Valley. I can tell you the recession has definitely affected job hiring. A lot of people are fired. So all the big companies are having layoffs. How do I get intern? I'm third year from India. I can't speak specifically for India, but you can apply. So you can apply. There are a lot of international positions. You just go to like Google, Facebook, Amazon. Everybody has international. So Amazon and Google both have huge offices in India. If you go to the website and you apply to those places, in India is a little bit, the chances are a bit higher. But anyway, let's go on and talk about the answer discussion because it's actually pretty late at night for me, even though it's during the day for you guys. So I need to finish up and get back and go sleep. Okay, so Contest 384 has just concluded, and now we will be discussing the answers. If you're watching this as a VOD, the contest link is in the description. Try it out yourself first. That's always the best way to learn, which is by doing. So come by every weekend to learn and code along with me. This is Alex Does LeetCode. For today, I think this is, in my opinion, one of the easier weeks. I don't remember a week that's easier than this. Most of the time, the questions are quite killer. Once again, I will be discussing contents, all 4 questions in turn. And if you're watching a VOD, please use the bookmarks to jump ahead. If you enjoy my contents, please like and subscribe to my channel. It really helps small-time creators like myself and keeps you notified when I do another video or contest stream. My next video will probably be answering questions about interviews, because that's something I know a little bit more about, having worked in FANG for quite a long time. Alright. See, I see a bunch of stuff. Purple Crayon from India got rank 1. Congrats. Last week was also easy. I don't remember last week. I thought it was quite hard. Well, maybe you did better than me, Kazi man. Alright, so let's get going. So let's start with question 1. Question 1. Modify the matrix. Given a zero-index m times n integer matrix, create a new zero-index matrix called answer. Make answer equal to matrix. Then replace each element with each element value -1 with the maximum element in this column. So basically how this works is you take this, you want to turn it into this. They are identical, except you define all the -1 and get the maximum. Oh, sorry. You're trying to get the maximum of the original column, which is this 9. And then you put it here, okay? So this is not the hardest question. So the way to do it is quite straightforward. What you do, exactly what the question says. I created the length m and n. You create a 2-dimensional array. In Python, you can use this comprehension syntax. If you're using Python, quick hint, you have to do this. In Python, you cannot say 0 times n, 0 times n, because that will cause you an error. Okay, and then you do a nested loop. You just iterate over the whole array. And what you do is, if it's not -1, then you set it to the same. You set it answer equals matrix. If it is, then what you do is you find the largest number in that column. So you replace this -1 with the largest number in this column, which is 9. And to do that, the way I did it, which is the most straightforward, is you just have a for loop. Most equals to the max of most, and matrix I column. So column is fixed, I keeps changing, and you iterate over all the rows and find the largest number at column call. Okay, that's it for question 1. Question 2. Number of subarrays that match a pattern I. Sorry, let me answer questions for question 1 first. So Aniket Chavan, first calculate max for each column, and next append on -1. Next append. Yeah, you can do that too. I just felt the matrix was not big enough for me to care. Yeah, but if there's a lot of -1s, it's a very big matrix, then that is definitely faster. Okay, question 2. Number of subarrays that match pattern 1. So you're given a 0-index integer array nums of n, 0-index integer array pattern of size m, consisting of -1, 0, and 1. And then you're supposed to do this pattern matching thing, where you say a subarray matches a pattern if the following condition is true for each item in pattern. So there's this thing here. It took me a while actually to understand what's going on, but basically I'm going to draw it out so that everybody can see what it is. 3, 4, 5, 6. The idea is the pattern, what's 1, 0, -1, is basically directions, right? So this pattern, 1 means up, -1 means down. So what you do is you convert this initial array into directions, into the same direction as pattern. So 1 to 2 goes up. 2 to 3 also goes up. 3 to 4 goes up. 4 to 5 goes up. 5 to 6 goes up. So the length of the pattern is 1 less than the length of the input array. So you look at and so because it's up, so this is 1, 1, 1, 1, 1. And now what you want to do is to say, where does this 1, 1 appear? Well, it appears here. It appears here. It appears like here and here. So that's 4. So the answer is 4. So same thing for here. I want to do it again because I was very confused by this pattern, this question when I first saw it. So I want to make sure everybody understands what this question is asking for. So 1, 4, 4, 1, 3, 5, 5, 3. So same thing, convert the direction. 1 to 4 goes up. 4 to 4, it is even. It's like level. It doesn't go up. 4 to 1 goes down. 1 to 3 up. 3 to 5 up. 5 to 5 even. 5 to 3 down. And 3 is nothing. So our pattern, when this basically converts to 1, 0, -1, 1, 1, 0, -1. So now we want to look for this pattern, right? 1, 0, -1. So where does it occur? It occurs here and it occurs here. So it occurs in 2 different places. Okay, so it occurs in 2 different places. The answer is going to be 2. So how do you tackle this problem? Well, the way I did it is as follows. So basically, I have count matching subarrays. I start with count, and then what I do is I basically have an array. I didn't actually convert the whole pattern, the whole nums into the pattern. I could do that. But instead, what I did was I just convert part of it, and then I keep going. And as you know, this might be more complicated than it needs to be, but basically I keep like a window of size pattern because I want to avoid instantiating multiple arrays in Python. That is a very slow operation. So I sort of append to the left and I append to the right and delete from the left. I keep going and move this window forward. So the window basically contains this pattern, this 1 0 1 1 0 1 minus 1 kind of pattern. And at every step, I just compare if this is accurate. If it is, I do count plus 1 and then counts. I have an auxiliary function here that helps me turn 2 numbers into 1, 0, or minus 1 by comparing them. So this question is actually not super hard. I thought the hardest part was actually trying to figure out what the question is talking about. Okay, now I'm going to jump. So I'm going to jump ahead now to question 4. So question 4, unfortunately, I didn't actually manage to do it myself. I look for hint, right? I look for hints. There's this KMP algorithm that you can use. I actually didn't know this. So it looks like green, but I take no credit for this. This is not my original work. This is thanks to Swastik and can't remember who else in the chat. Swastik and Sumai Agrawal in the chat. So thanks to you guys. You guys are real MVPs. So essentially what I did here, after getting the hint from them, is I use this KMP search. So I can Google it. Pattern matching. And you can understand what it's really talking about. So to sort of summarize, I don't know it super well either. But to summarize, basically you compute this thing called LPS, which is you count how many patterns before it. You count how many patterns match the suffix. Yeah. So basically, you know, it's a very standard algorithm. Sorry. I want to make sure. Yeah. Yeah. It's a standard algorithm. You just apply the algorithm. So here I first convert the entire nums into this 1 0 minus 1 minus 1 0 1 whatever pattern, and then I search for it inside here. Yeah, that's pretty much all I can say about it. You know, unfortunately, again, credit goes to the folks in the chat. I take no credit for answering this question. Yeah, on my own device, I would probably have timed out. So I actually tried a few things, if you guys are interested. So one thing I tried is to optimize this a little bit. I tried a few things. One of the things I tried initially was, while I'm comparing, I actually keep a count. So at every stage, I keep a count of how many pluses, zeros, and minus ones I have. So I thought that would make it easier. So if, you know, the total number of zeros, 1, and minus 1s don't match, then I'll skip that stage. The reason why this doesn't work for a very large n, if you look at this, if this n is very large, the reason why it doesn't work is actually because of this comparison. So matching the window, or matching, like, you know, whatever, you know, the long thing to the pattern actually takes a long time. Yeah. Third question. Okay, awesome. People have spoken. So third question actually is, you know, it's one of those questions where it's actually a math question disguised as a programming question. It's a mathematics question, right? If you understand the mathematics, you can solve it very, very easily. If you don't understand the mathematics, then it's a bit trickier to solve. So basically, let's look at the question first. So you are given a zero index string array words having length n and containing zero index strings. So something like this. And you want to perform this operation any number of times, including 0. So you can perform this any number of times. You're not trying to minimize the number of times you perform it. You just do it as many times as you want. Basically, what you're doing is you're picking I, J, J, X. What this thing is saying is you can swap any two characters in any two words. Okay? So you can swap any two characters in any two words. Let me just check if that's true. Yeah. In fact, I think if I read this carefully, now that I'm reading carefully, I and J can be the same. So you can swap letters in the same word also. So any two characters in any words, and you can swap them any number of times. And your goal is to construct as many palindromes as possible. So for instance, in this example, you have A, B, 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 A, A, A. You can swap them around until you get B, 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 A, A, and A, A. Okay, to get 3 palindromes. So likewise, this one A, B, C, A, B. You can keep swapping them around. You get A, C, A, B, B. So this is again 3 palindromes. And now this one, C, D, E, F, A. Wow, this guy basically 0 palindromes. Why? Because they're all different letters. Only this word, which is a single, which is one character, can be turned into a palindrome. No other thing can be turned into a palindrome. Okay? So, before we start coding, let's think about what we're actually coding for, right? How do we tell? First of all, how do we tell this? How do we tell how many palindromes we can construct? Well, the sort of brute force way is to just keep making this operation until it works, right? But that's not the best way. Instead, we're going to use some mathematics to help us. So, the observation is 1. You can keep swapping things around. So, as long as there are letters that's even, you can make a word palindrome. Does that make sense? Let me try to rephrase it. Let me try to rephrase it. Let me try to rephrase it. 1. If word length is even, it will require all even characters to be a palindrome, right? So if a word is even, you will require, and it has length n, you basically need n over 2 letters, all of whom occur at least twice. Okay? But if a word, the length is odd, then it can have all even characters plus 1 odd. Plus 1 odd character. So let's see if I can turn that into an example. So take a look at this example. A, B, C, A, B. So A, how many A's do we have? Because look, because we can just use this any number of times we want, right? You can just swap any number of times we want, right? So really we don't care where the letter started. We just need to know how many A's we have, right? We have 2 A's, we have 2 B's, and we have 1 C. Okay? And then we count how many words we have. We have 1 word that's length 3 and 1 word that is length 2, right? This one is length 3 and this one is length 2. Okay? So far so good. We have 2 A's, 2 B's, and 1 C. We have 1 word that's length 3 and 1 word is length 2. So if we have a word that is length 2, we need to use letters whose total is even. Right? So we cannot use this C. C does not go into here. It does not go into, C cannot be used because there's only 1 C left. It cannot be used in words with even length. It can only be used in words with an odd length. Okay? So C's require odd length word. Whereas, and this this tree actually can use ABA, right? If it's odd length words are very powerful. They're great. You can use whatever you want. But letters that are odd numbered, there's only one C. Okay? Eventually, you need to find a home for the last C. It has to be an odd length word. It cannot be an even length word. It's the same thing for if C, for instance, is like 7. If we have 7 C's, right? We have 7 C's, right? 6 of the C's can go into here and here, but the last C can only go into a word of odd length. So this is a bit tricky. I hope this is a useful explanation. So the idea here, is to count. Basically, first thing we do is to count how many letters we have, right? How many A's, how many B's, how many C's, and then we look at how many letters we have an odd number of. So letters that we have an odd number of need to find a home in a word of odd length. Does that make sense? So same thing. For example 3, we have C, D, E, F, and A. A equals to 1, B, oh no, not B. So C equals to 1, D equals to 1, E equals to 1, F equals to 1. Okay? Of the words, we have length 1, length 2, and length 2. Because all these are odd, these letters all have odd counts, they can only go into this guy. These guys cannot take these letters, right? So from there, we can basically, to sum it up, basically what we do is to count how many letters have an odd number total of words, and these odd letters will have to go into words that are of odd length. So you count how many odd words there are and how many odd letters there are. Okay? So this is basically what I did. It's a bit more roundabout. Essentially, the first thing I did is to create a frequency dictionary. The frequency dictionary will compute this. And this frequency dictionary also counts this thing called odd words. So odd words would tell you how many words are odd length. Okay? After we're done this, we actually don't need this. After we've done this, we have odd words versus number of odd characters who have odd counts. If there are more odd words than odd characters, so there is more greater or equal. So for instance, this one, there is there's one character with an odd number count. So C has 7 characters, that's odd number count, and there's only one word with an odd number count. Okay, so 1 and 1, this matches. If this matches, then all the words can be turned into palindromes. Because all the letters with odd counts, you have to find homes for them, and we have enough words of odd length to fit them in, right? So you notice that words of odd length like A, B, C, the middle guy can be anything. The other the other sides have to fill up. So odd length. Otherwise, what do? We take the odd numbers. We take the characters that are like leftovers, like these odds. This C is an odd. There's an extra C somewhere with no pair, with no buddy. We will stash these guys in the longest possible word. We have unused odds equals to odds minus odd words. And then what I did is I reverse sort the words by length. So the longest word will be first. And what I do is I stick those random assorted letters into the longest word first. And I keep doing that, and I see how many words will not be able to turn into palindromes. And that's what this mist is doing. And once I've done that, I just take the length of words minus mist. Mist is the number of words that cannot be turned into palindromes. Since they are not able to turn into palindromes, I can throw all my odd letters into my leftover letters into them. Yeah. So if I do that, I basically run it, submit. Yeah. And that will give you the correct answer. I think this is actually a very small complexity problem. This is actually a very slow way of doing it. I'm sure there's like faster way. But because the size of the problem is fairly small, it doesn't matter. It passes anyway. Okay. So yeah, let me see. There any questions in the chat? Nope, no questions in the chat. Great. So this concludes tonight's stream. Thank you very much for showing up. Once again, if you enjoy my content, throw me a like and a subscribe. It helps me so much, you don't even know. All right. I hope to see you guys next week. I think it will be Saturday, 9:30 a.m. Eastern Time, and I believe it's 8 p.m. IST. This is once again Alex Does LeetCode. See you all. Bye-bye.